Okay, thank you for coming, everybody. I normally have double the amount of time to give this talk that I have today, so I'm going to talk faster than I normally talk. Try to listen fast. I'll try not to talk too fast. If you miss anything, I'm sure this will be online at some point, or you can email me. I'm happy to send you the presentation. If you are curious to get links to any of the studies that I cite today, again, please email me. Happy to send you links to the studies. Since I have a limited time, we're going to do this Ted Naiman style. If anyone knows Ted Naiman or has seen his low-carb Breckenridge video on hyperinsulinemia, he blew through that very quickly, right? Barely stopped to take a breath. That's kind of how we have to go. Except I'm going to keep my shirt on, and I might smile a little bit. So if any of you know Ted Naiman, we're only doing it half Ted Naiman style. I would like us to keep something in mind as we go through the talk, and that is, when it comes to things like type 2 diabetes, obesity, cardiovascular disease, we take it for granted that there's a role for diet and lifestyle in those illnesses, right? We don't even question that anymore. We take that as a fact. And not only is there a role for those things in those illnesses, there's a primary driving role, right? And yet, when it comes to Alzheimer's, we just throw our hands up. We're clueless. We have no idea where this is coming from, right? It couldn't possibly be a dietary and lifestyle condition in the same way that all of those other chronic, non-communicable diseases are that have exploded in incidence over the last half century, right? Okay, something else I'm going to tell you is, if anyone here is a giant nerd and was a big fan of the show Quantum Leap, in the last episode of the show Quantum Leap, Sam the time traveler goes back in time and he meets Al's wife. And he says to her, I'm going to tell you a story, and it's a story with a happy ending. But instead of once upon a time, let's start with the happy ending. The happy ending here is that there is something we can do about Alzheimer's disease. Certainly, there are a lot of unanswered questions remaining and a lot of research remains to be done, but that doesn't mean we're completely clueless. We know a lot more about this than we're led to believe we do. I'm going to talk to you about Alzheimer's disease as a metabolic condition. And by metabolic, I mean it has to do with the way the brain gets energy. So how do you feel when you don't have enough energy, when you get tired? You get clumsy, right? You make mistakes you don't normally make. So what do you think happens to the brain when the brain gets tired and the brain doesn't have enough energy? So we're going to make the case it's a metabolic condition. Alzheimer's disease is essentially a fuel shortage in the brain. It's an energy crisis in the brain. Your brain is an energy hog. Depending on the source you cite, your brain uses anywhere from 20 to 25% of all the glucose and oxygen in your body. Anything that disrupts that supply of energy to the brain is going to have catastrophic implications for cognition. When the brain's energy supply is insufficient to meet its metabolic needs, the neurons that work the hardest, especially those concerned with memory and cognition, are among the first to exhibit functional capacity, impairment of memory and cognitive performance. Remember, even when you're asleep, even when you're watching reality TV and you can feel your brain leaking out of your ear, your brain needs a constant supply of a lot of energy. If we're going to understand what's going wrong in the Alzheimer's brain, we have to look at the basic neuron structure. This is a very simplified look at a neuron. If you look toward the left, you see kind of the larger part that's called the cell body. It's got this long, thin projection coming out of it that's called an axon, and the axon ends in these little buds called axon terminals that you see at the right. So one thing to keep in mind is that in order for this neuron to be built correctly and function correctly, it has to have the right raw materials, the right building blocks. And the way that neuronal communication happens, it's kind of like a radio station with transmitters and receivers. So a nerve impulse is passed down the axon of one neuron, and it's received at the dendrites of another. And there's the axons and dendrites don't actually touch. There's a very, very tiny space between them, and that space is called a synapse. Some of you are probably well aware of all this, but some of you might be new, so I'm just kind of going through the basics. One of the things that happens in Alzheimer's disease, because the brain doesn't have enough energy, in order to conserve energy, to keep the cell body alive, in order to keep this cell viable, the cell actually pulls back in those axons and dendrites because it takes energy just to maintain that structure. So instead of nice, beautiful synapses that look like this, we have that. Those two neurons are no longer able to communicate with each other. That synapse has been lost. It's no wonder that person is losing their memory, they're having personality changes, their behavior's changing. So keep in mind, because we're going to come back to this, the axon is surrounded in something called the myelin sheath, and it's made out of a substance called myelin. And myelin surrounds and insulates and protects the axon in the same way that the electrical cords in the appliances in your home have kind of a rubbery, plasticky protective coating. You need three main things to make myelin. You need fat, you need cholesterol, and you need vitamin B12. Fat, cholesterol, B12, remember those. So again, basic schematic of a nerve impulse transmission. It's coming down the axon, being received at the dendrites, tiny space in between called a synapse. Again, super nerd. If anyone here was a fan of Carl Sagan, I had a huge nerd crush on him. Carl Sagan's famous tagline was billions and billions, right? So you have billions and billions of neurons in your brain. And each neuron has multiple synapses, multiple connections with other neurons. So you have trillions and trillions of synapses in your brain. Kind of just looks like a big tangled mess of axons and dendrites. I hope nobody's having scary flashbacks to high school biology class. Don't get scared, it's only a cell membrane. I don't know if there's a pointer here or not, but those little yellow tails you see sticking up and down in that cell membrane, what are those? Fats, right? Fatty acids. You need all different kinds of fats for healthy cognition and proper brain cell structure, but you especially need omega-3 fats. The omega-3 fat DHA is very, very abundant in the neurons. And the sort of brighter yellow little squiggly pieces you see, what's that? Cholesterol. What do you need for good, healthy cell membranes? Fat and cholesterol. Don't forget that. So why are cell membranes so important? Cell membranes are the bouncers of your cell, right? They're security guards. They determine who gets to come in and who has to get kicked out. Things that come in are glucose, ketones, amino acids, fuels, nutrients, things that get kicked out, toxic waste products, normal metabolic waste that have to be gotten rid of. In order for that to happen correctly, you need your cell membrane to function properly. And it's not going to function properly if it's not built correctly. You wouldn't hire some scrawny weakling to be the bouncer at your club, right? You need a big, brawny, burly dude who's going to do the job right. Same thing, you want brawny, strong cell membranes. So if we're talking about energy, and we're saying Alzheimer's is a fuel shortage in the brain, probably going to come back to mitochondria, right? Why? Mitochondria are the literal site of energy generation in your cells, except for the very small amount that happens in the cytosol. The mitochondria are responsible for the vast majority of energy production in your cells. And we just covered the cell membrane, but look at the mitochondria. Some of you may not know, a mitochondria doesn't have one membrane, it has two membranes. It's got an outer portion surrounding the whole capsule, and it's got the inner portion, the squiggly portion, that's the matrix. Both of them are surrounded by membranes. So if there's an energy problem in the brain, there's probably something somehow wrong with mitochondria, right? If the amount of free radical species produced overwhelms the neuronal capacity to neutralize them, oxidative stress occurs, followed by mitochondrial dysfunction and neuronal damage. Now, to be honest, I think oxidative stress is actually getting a bad rap in the health world. Oxidation is a normal process. It's a necessary process. It actually performs a signaling type of role. It's why studies where they give massive doses of antioxidants usually have pretty bad outcomes, because your body does need some amount of oxidation. It's only when it's sort of uncontrolled and overwhelms the cell's ability to neutralize it and repair that it becomes a problem. Mitochondrial dysfunction and the resulting energy deficit trigger the onset of neuronal degeneration and death. These cells are dying because they are essentially starving to death. Alzheimer's disease is neuronal starvation. It's the energy deficit that's triggering the neuronal degeneration. This is like the money shot. This is what we're here for. They are now regularly referring to Alzheimer's disease in the medical literature as type 3 diabetes, diabetes of the brain, or brain insulin resistance. And where this comes from is the primary pathological signature of this illness is neurons in affected regions of the brain lose the ability to harness energy from glucose. So they're, like I said, they're basically starving to death. The predominant abnormality in late onset Alzheimer's is a 45% reduction in cerebral glucose utilization. 45%! If your brain is using 45% less energy than a healthy person's brain, do you think you might have some cognitive impairment? Do you think that might affect your memory and your behavior? You bet it does. Progress in understanding changes in brain energy metabolism during aging and Alzheimer's has grown rapidly in the past 3 decades, to the extent that it is now widely acknowledged that brain hypometabolism accompanies Alzheimer's. Let's parse this a bit. Brain hypometabolism, too little metabolism, not enough energy. This is widely accepted. Who knew? For many of you, this may be the first time you've ever heard this, but this has been known for 3 decades. Who here has been hearing about this for 30 years? Do I see one? I think I see one hand. You might be a rock star. You're ahead of the curve, because this was brand new to me. A prominent and well-characterized feature of Alzheimer's is progressive, region-specific declines in cerebral metabolic rate of glucose. Let's break this apart. Alzheimer's disease is a progressive illness, right? Nobody wakes up all of a sudden with severe dementia. This is something that starts in a mild form, and it gets worse and worse and worse until you have full-blown Alzheimer's disease. And it's region-specific. What that means is, at least in the early stages of this condition, the whole brain is not affected. It's only certain regions, because we know this, right? People in the early stages may be a little bit forgetful, maybe doing strange things, but they can still bathe themselves, they can feed themselves, basic hygiene. By the very, very late severe stages of this, they can't even do that. Their whole mind is gone. So at first, though, it is region-specific. Reductions in regional cerebral glucose metabolic rate are associated with increased Alzheimer's risk, can be observed years before dementia onset. That might be one of the most important things in this entire talk. Alzheimer's disease is not a disease of old people. They used to call this old-timers disease, right, kind of flippantly. They can measure this decline in cerebral glucose use in people as young as their 30s and 40s. And the thing is, at that age, the brain is still healthy enough and they're still robust enough that the brain is compensating. Even though the brain is already using less glucose than a healthy person, you are asymptomatic, no signs and symptoms of Alzheimer's. The signs and symptoms only begin to manifest when you reach a threshold where the brain can no longer compensate. That's when you start losing your memory. That's when things start becoming a problem. But by the time that happens, the disease process has already been in place for years, and in some people, decades. And I think that is part of why this is so difficult to turn around and so difficult to make an impact in. This is not like type 2 diabetes. It's not like obesity, where you can make a pretty big dent in it in a relatively short amount of time. This is kind of a different animal. Now, I love, love, love the phrase type 3 diabetes. However, it's a little bit misleading. There's a problem with how we diagnose type 2 diabetes. And if I ever just say diabetes, please know I'm referring to type 2. I don't mean type 1. It's a very different thing. People get very, upset about that. So if I just say diabetes, it's type 2. The way that we diagnose type 2 diabetes is based solely on blood glucose. It's based on fasting glucose, A1C, or sometimes the response to the oral glucose tolerance test. They never look at insulin. And there are quite literally millions of people walking around right now, maybe some of us in this room, with perfectly normal blood sugar, perfectly normal A1C. Those things are only normal because they're being kept in check by sky-high insulin, chronic hyperinsulinemia. And there's so many conditions that are related to this in people with or without normal blood sugar. Don't have time to run through them all. This is probably old news to most of you anyway. We know PCOS is a hyperinsulinemic condition. Hypertension generally goes away real quick on a low-carb diet. Erectile dysfunction, men, ED is not a libido problem. It's a cardiovascular problem. And cardiovascular problems are insulin problems. So I want to give credit to Ivor Cummins, who is here with us today all the way from Ireland. He's the one who's brought the work of Dr. Joseph Kraft back to the spotlight. And I never even heard of Dr. Kraft before Ivor started writing about him. It's some of the most important, most fascinating stuff I've learned in the past couple of years. Dr. Kraft is the one who pioneered the oral glucose, what's now known as the Kraft test. It's the oral glucose tolerance test with the insulin assay. So instead of just testing your glucose, they test the insulin. And Kraft is the one who uncovered this huge, huge buried iceberg of these people with normal blood sugar who were not diabetic, but they're hyperinsulinemic. So if you have chronic hyperinsulinemia, you are at greater risk for Alzheimer's disease, period, regardless of your family history, regardless of your genetics. If you are chronically swimming in insulin, you're at increased risk for Alzheimer's. The risk of Alzheimer's doubled in 39% of a study sample with hyperinsulinemia, was highest in people without diabetes. This is Dr. Kraft in action. These people have what Kraft called diabetes in situ, or occult diabetes. Occult meaning hidden. The diabetes, the high glucose, is hidden by the high insulin. So I think Dr. Kraft and Ivor would probably think these people are diabetic, they're just not diagnosed. Insulin resistance may be a marker of Alzheimer's risk associated with reduced cerebral metabolic rate of glucose, subtle cognitive impairments at the earliest stage of disease before the onset of mild cognitive impairment. Remember, this is your canary in the coal mine, guys. This is the first domino to fall. The chronic hyperinsulinemia, the reduced brain glucose metabolism are the first dominoes to fall. They happen well before signs and symptoms start to manifest, well before anything else that we take for granted in this illness. All right, if we're going to talk about risk for Alzheimer's, there's hyperinsulinemia. What about E4? There's probably some E4s in this room who are very scared of this illness, and I can't tell you not to be scared. You need to feel the way you need to feel, but I hope that I can put some perspective into this. ApoE4 right now is the strongest known genetic risk factor for Alzheimer's. They call it the Alzheimer's gene, but I think that's really misleading. First of all, so we get 2 copies of every gene, right? One from our mother, one from our father. People with 1 copy of E4 are at increased risk for Alzheimer's. People with 2 copies, homozygous, are like exponentially increased risk. It's something on the order of 50 to 90% chance that you will get Alzheimer's if you're homozygous E4. However, there's lots and lots of people who are homozygous for E4 who do not develop Alzheimer's, and millions of people who have Alzheimer's don't even carry 1 copy of E4, let alone 2. So this gene doesn't cause Alzheimer's. Nobody's genetically programmed to get Alzheimer's disease. One of the largest concentrations of the ApoE4 gene is tribes in Nigeria. They're super, super high E4s. You know what they don't have? Alzheimer's disease. So the fascinating thing about E4 is it is hypothesized that E4 is the oldest hominid, most ape-like allele of the ApoE gene. And like the ApoE2 and 3 are believed to have appeared later in human evolution, being that this is the oldest one, this one is believed to have been forged in our hunter-gatherer times. So it's not that E4 causes Alzheimer's. E4 is just the worst mismatch for the way we eat and live in the 20th and 21st centuries. It's just these people suffer the most with tons of refined carbs, tons of vegetable oils, not sleeping, all the things that are incongruent with how this gene was forged. It should be noted that E4 is not an inherently damaging allele. It is only deleterious in combination with a high-carb diet, which is deleterious on its own. Again, same thing. E4, not really damaging by itself, only in combination with high carbs, and that causes all these other chronic non-communicable illnesses, even in people without E4. So if you have E4, I wouldn't be too worried if you eat the way you eat at this conference. So we talked about the ApoE4. If we're going to talk about risk, we also have to talk about amyloid. What is this fish doing on my slide? What is this red fish doing on my slide? Do you know what kind of a fish that is? It's a herring, and it's a red herring, because amyloid plaques and beta amyloid proteins are red herrings. They're not total red herrings, they're not meaningless, but let's dissect what this stuff actually is and does. Low regional cerebral metabolic rate of glucose is a very early event in the disease process, well before any clinical signs of dementia are evident, and well before a cell loss or plaque deposition is predicted to have occurred. The buildup of these amyloid plaques in most cases is a late player to the game. Again, the lowered brain glucose metabolism is the earliest step. These plaques don't come into play until later. So what are amyloid proteins? What are amyloid plaques? Basic explanation, beta amyloid is a protein secreted by your neurons, and it's secreted by other cells too, but we're mostly concerned with the neurons here. And again, just like oxidation, this is a normal process. It happens in healthy brains too. The problem in Alzheimer's is that these proteins are not cleared away properly. They sort of build up and accumulate, and when they build up to a certain concentration, they solidify and they may cross-link into each other, they get glycated, they form these infamous amyloid plaques. It's this gunky, sticky mess in the brain. And these plaques actually do get in the way of those synapses. They do block neuronal communication. So when I said it's not a total red herring, they are kind of meaningful, but not in the way we think. There's a lot more evidence that these amyloid proteins are actually protective, and that trying to get rid of them willy-nilly may actually be making things worse. One thing to know, they're actually not supposed to diagnose Alzheimer's disease in a living person. They're supposed to diagnose you with Alzheimer-like dementia or suspected Alzheimer's. And the reason is because this is only supposed to be formally diagnosed upon autopsy, when they look at your brain and they look for the plaques. But guess what? Lots and lots of people who die from Alzheimer's disease do not have significant plaque buildup, and lots of people who die from other causes with no signs or symptoms of dementia or Alzheimer's are found to have significant plaque buildup. So either these plaques are not a cause of Alzheimer's, or they're not the main cause. We need to figure out a little more about what they're doing. Again, basic graphical representation of what it looks like, this gunk that just builds up extracellularly outside, getting in the way of neuronal communication. It's more and more coming to light that amyloid is protective. So many of you in the room have probably heard the name Dale Bredesen. He's an MD. He wrote a book called The End of Alzheimer's, highly recommended. The production of the amyloid is a protective response. The idea of just getting rid of the amyloid without understanding why it's there actually makes very little biological sense. Formation of beta amyloid may be an element in the brain's defense against oxidative stress. Oxidative stress may provoke the protective release of beta amyloid. Over and over and over again, this amyloid has been shown to be protective in multiple ways. And there's been several drugs now, at least 3 or 4, maybe more, drugs that have been developed to reduce the secretion of the amyloid or reduce formation of the plaques. Every single one of these drugs has been a failure. Now, they've been a success in that they do reduce the formation of the proteins and plaques, but reduced amyloid buildup in the brain does nothing to stop the disease process. It does nothing to stop the Alzheimer's from getting worse. In fact, the phase 3 clinical trials of one of these drugs had to be stopped early because the people on the drug were doing so much worse than the people on the placebo that it was deemed unethical to continue. So this amyloid, it's not what we think it is. And remember, it's not a problem that this beta amyloid protein is being secreted. The problem in the Alzheimer's brain is it's not being cleared away effectively. So we've got these drugs, we've got this substance we've demonized, this seemingly very healthful, good, beneficial substance that we've demonized. And if we could just eradicate it altogether, if we could get rid of every molecule of amyloid, we've just cured Alzheimer's. Does that remind anyone of anything else? Any other beneficial substance that we're trying to get rid of as much as possible, and it hasn't worked out so well for us. So remember the analogy, cholesterol is to cardiovascular disease as amyloid is to Alzheimer's. And again, I'm not saying that amyloid is completely benign. I mean, I liken the amyloid protein buildup to a fever. So a fever is your body's protective mechanism, right? You're trying to raise your core temperature in order to fight off some invading pathogen. But if the fever goes too high, then the fever itself becomes a problem. I think it's kind of the same way with the amyloid. It may initially be protective, but because it's not being cleared away and it's now building up and solidifying into plaques, now it's a problem. So it's not that the amyloid is totally, like we shouldn't ever try to get rid of it, but it's just not what we think. Can we tie this back to insulin? Yeah, you bet we can. So I just said that the problem in the Alzheimer's brain is that these proteins are not being cleared away effectively. Oddly enough, the thing that's responsible for clearing away amyloid protein is a little enzyme called insulin-degrading enzyme. What? So insulin-degrading enzyme does exactly like what it sounds like it does. It clears away insulin. Hormones can't just linger in the bloodstream forever. Something has to come and clear them away. So that's what IDE, insulin-degrading enzyme, does. But a lot of enzymes in the body have multiple targets, or what we call substrates, multiple different things they can work on. IDE is one of them. It has multiple targets, and parents who have more than one child always claim they don't have a favorite child, right? They don't pick. Even if they do, they'll say, I don't have a favorite. Enzymes are not like that. Enzymes do pick favorites. And the favorite child of IDE is insulin. So that means whenever there's significant amounts of insulin, the insulin-degrading enzyme is busy clearing away all the insulin, leaving all its other targets to just be left behind. One of the other targets this enzyme degrades is amyloid proteins. How crazy is that? That's amazing. Under hyperinsulinemic conditions, insulin competes with beta amyloid for insulin-degrading enzyme, leading to the accumulation of beta amyloid and senile plaque formation. Insulin-degrading enzyme, a major beta amyloid degrading enzyme, might be what we call competitively inhibited by insulin, resulting in decreased amyloid degradation. It's been shown that elevated insulin levels in type 2 diabetes, and I would argue all the hyperinsulinemic people who are just not diagnosed diabetics, this induces beta amyloid accumulation through competition between insulin and beta amyloid for IDE. You understand this, right? How crazy this is? Alzheimer's disease is your brain on Krispy Kremes. It's your brain on sugar, it's your brain on refined carbs, it's your brain on these corn oil. There's more to it. I'm not trying to oversimplify. There's a lot of other factors, but just remember the donuts because that'll help you keep this in mind. Are there other things that get in the way of healthy cognition? Yeah, there sure are, especially when we're talking about our parents, our grandparents, anyone as we age. How many of our parents, grandparents, maybe even us, are on prescription antacids? These drugs were never intended to be taken for the long term, never intended to be taken for 10, 20, 30 years. What did I say about the myelin sheath? Vitamin B12? You know what you need to absorb vitamin B12? Stomach acid. I heard it from someone. Your stomach is supposed to be acidic. There is a reason there is hydrochloric acid in your stomach. It does no good to eat the most fancy schmancy, organic, grass-fed, artisanal food if you're not actually digesting and absorbing it. There's that phrase, you are what you eat. You are not what you eat. Haven't you all seen corn you know where coming out, leafy greens? You're not what you eat. You are what you digest and absorb and assimilate. Prescription antacids reduce stomach acid to the point that you may become deficient in critical nutrients. And I specifically called out B12 because that's a biggie, but brain healthy cognition doesn't happen in a vacuum. It doesn't happen by magic. You need certain nutrients to construct all those cell membranes, to have proper neuronal communication. Iron, zinc, magnesium, choline. This stuff doesn't happen by itself. So glad that Dr. Ali, who's right here in the front, and Dave Feldman spoke yesterday, because nobody's afraid of cholesterol anymore, if you were even before you came here. Statin drugs have some very, very alarming implications for cognition, especially long-term use. Everything you're going to see in the next couple of slides comes directly from the US FDA's website. Adverse information from statins. The potential for generally non-serious and reversible cognitive side effects, memory loss, confusion, reports of increased blood sugar and glycosylated hemoglobin levels have been added to statin labels. Yes, statins increase risk for type 2 diabetes. I think Dr. Ali covered that. That could be a whole other talk, that mechanism. The FDA continues to believe that the cardiovascular benefits of statins outweigh these small increased risks. Do you know what that means in plain English? The cardiovascular benefits, if there are any, outweigh these small increased risks. I'll say that in plain English. Congratulations, Mr. Jones. You've got the lowest cholesterol in the dementia ward. I mean, are you kidding me? Are you kidding me with this? So again, adverse information. This is what they show patients on the website. Memory loss and confusion have been reported with statin use. These reported events were generally not serious and went away once the drug was no longer being taken. This is what they tell the doctors. Rare post-marketing reports of cognitive impairment, memory loss, forgetfulness, amnesia, memory impairment, associated with statin use. Again, generally not serious, reversible upon statin discontinuation. Okay, first of all, how many doctors tell their patients to stop taking their statin? If anything, it's fear-mongering way to the other side. Don't you dare stop that for even 5 minutes. And then, these symptoms are generally not serious. When my husband or my best friend or my neighbor or my child doesn't recognize me, doesn't know my name, can't find their way home, don't tell me that's not serious. I don't know how they get away with this. That sounds pretty darn serious to me. It has been shown over and over and over and over again that high cholesterol seems to be beneficial as we age. No reason to be afraid of cholesterol anymore. High LDL-C. The LDL is inversely associated with mortality in most people over 60. Inversely associated, right? The higher your cholesterol, the longer you live. Now, I like to kind of put this in perspective. It bothers me when they say, lower risk for mortality. No. Everybody here has 100% risk for mortality, right? None of us is getting out of this alive unless, depending on your religion, you might believe there's one person who escaped that, but It just means that your risk of dying from anything other than a nice, happy old age is lower. Non-demented elderly with levels of total cholesterol, non-HDL-C, and LDL in the lowest quartile were approximately twice as likely to die than those in the highest quartile. High cholesterol increasingly all the time shown to be associated with increased cognitive, better cognitive function, decreased dementia risk. They did a study in very elderly Chinese people. Total cholesterol levels within the high normal range are associated with better cognitive performance, especially in the oldest of the old people. They decide that low cholesterol can serve as a clinical indicator for cognitive impairment, risk for cognitive impairment in the elderly. When I get a client, I'm a nutritionist, when I get a client with like freakishly low cholesterol, I don't pat them on the back and say, congratulations. I say, what's going on here? And maybe it doesn't mean anything bad, but I don't immediately get happy. Low cholesterol to me, especially in an older person, especially in an older woman, is a little bit alarming to me, and I want to dig deeper and see what's going on. But no reason to be afraid of LDL as you age. All right, what are we going to do about this? If I didn't think we could do something, I wouldn't be here. If you didn't think we could do something about this, you wouldn't be here. What are we going to do about it? Alzheimer's disease may be similar to obesity, coronary artery disease, and type 2 diabetes in being a consequence of the conflict between our Paleolithic genetic constitution and our current Neolithic diet, right? This is the ApoE4 right here. It's just a mismatch. It's just we're eating and living wrong. Okay. We've been saying all along, Alzheimer's disease is an energy crisis, right? A fuel shortage in the brain. Well, but that fuel crisis is specific to glucose, right? These neurons have lost the ability to properly metabolize and harness energy from glucose. Well, wouldn't it be great? Wouldn't it be really great if there was some alternative fuel? Some other fuel that we could give these starving, struggling neurons? Well, what do you know? Anyone ever heard of ketones before? Anyone? Okay. So the most fascinating thing about Alzheimer's disease is that for whatever reason, even though these cells are not able to properly metabolize glucose, they can still take up and metabolize ketones. Now, an older, very severely demented brain is not going to do this as well as a younger, healthy person, but it can still do it. And they've shown this over and over in studies, not just in mice, not just in cultured neurons, in human subjects with mild cognitive impairment, which is the precursor to Alzheimer's, and full-blown Alzheimer's. This quote has one of my very favorite lines ever from the medical literature. This is from Sam Henderson, a pretty prominent Alzheimer's researcher. Throughout much of human evolution, ketosis likely served as a valuable survival mechanism to fuel brain metabolism during times of food scarcity, and I would argue during low carbohydrate intake, not just during starvation. In some ways, the modern diet can be considered keto deficient. That is one of my all-time favorite lines. And so is this, probably even more, from Stephen Cunnane, who's a researcher up in Canada. His work is stunning with ketones and Alzheimer's. 2 points are clear. Alzheimer's disease is at least in part exacerbated by, if not actually caused by, chronic progressive brain fuel starvation due specifically to brain glucose deficit. And attempting to treat the cognitive deficit early in Alzheimer's using ketogenic interventions is safe, ethical, and scientifically well-founded. Can I get an amen and a hallelujah? Okay. So glad we're all on the same page. And before I forget, I want to go back to insulin for 1 minute because I forgot something very important. They've done some studies, some of you you might be familiar with them, something called intranasal insulin. They administer insulin via a nasal spray, it gets into the brain, and the Alzheimer's subjects do have improved cognition. But it's a very short-term fix, right? That's not going to reverse Alzheimer's. One of the interesting things about this condition is that even though most of these people are wildly hyperinsulinemic in the periphery, the body outside the central nervous system, in the brain and the central nervous system, they're hypoinsulinemic. They have less insulin in the brain and cerebrospinal fluid than healthy people. But in my mind, so okay, let's give them the short-term fix. Let's give them the intranasal insulin. It'll help. Let's make all the other interventions too. But this intranasal insulin, in my mind, the answer is not to give them more insulin. The answer is to resensitize the brain to the insulin that's already trying to get in. It's like what we do with type 2 diabetics. You don't give people who are awash in insulin more insulin. You have interventions so that the stunning amounts of insulin that are already there do what they're supposed to do. So I did want to mention that because I think that's fascinating. How are we going to raise ketone levels? There's a lot of different ways. Don't have time to cover them all. You all know it anyway. I do want to hit real quickly on the coconut oil because many of you have probably heard of Dr. Mary Newport, whose husband had Alzheimer's. And she started out, she was a neonatologist, so she knew a little bit about the benefits of MCTs for the brain from the newborns and the preemies. She started out by putting coconut oil on her husband's oatmeal. That's all she did. He was still eating his habitual high-carb diet. He wasn't doing a keto diet. Just with that, just by adding a little bit of coconut oil, she noticed a significant enough improvement to spur her on to further research, and now she's very active in researching the ketone esters and salts. But we know that even when you're eating a high-carb diet, getting some ketones into your body somehow will help your cognition. I mean, her husband was markedly improved. So we have to talk about the exogenous ketones. Most of the research on Alzheimer's has been done on the exogenous because you can't give old, sick people egg yolks. You can't give them butter. So, I understand that's not, they don't want to do that research for now. In my opinion, normally, I don't recommend exogenous ketones because most of the clients who come to me are type 2 diabetics, they have obesity. Exogenous ketones are not a fat loss tool. So, and I think there's a little bit of misleading and misinformation in their marketing. That being said, I do think for neurological conditions, I think they can be really, really helpful, especially if you have somebody very, very elderly, very advanced dementia. You are not going to get that person to do a ketogenic diet. It's hard enough on them, let alone the caregiver. I mean, caregiving for somebody with dementia is hard enough, let alone trying to force them to eat things they don't want to eat and taking away their favorite foods, right? So in those cases, I do think you should give the exogenous ketones, but that's just a Band-Aid. It's covering the symptom because the ketones will improve cognition in the short term, but let's get one thing clear. Whether we're talking about Alzheimer's or diabetes or gout or PCOS or what, exogenous ketones do not induce all of the same metabolic and physiological changes that a ketogenic or low-carb diet does. So they're not useless. They have their time and place. But I like to say that giving exogenous ketones without changing the diet and lifestyle is like bailing water out of a leaky boat without stopping to patch the hole. You're just managing the crisis in the short term while the actual underlying problem is getting worse. So my advice is to do both. Do as much as you can to change the diet and lifestyle and give the ketones. And if you can't change the diet and lifestyle, yes, give the ketones. All right. I get the question a lot, do I need to follow a ketogenic diet to prevent this? If I've eaten the standard American garbage and I'm 30, I'm 40, I'm 50, is it too late? Am I already on the fast track to Alzheimer's? I don't think so. And I say potentially prevent because I don't know for sure that we can prevent this. I don't even know if there's a way to design a prospective study to see if we can prevent it. I believe we can. So assuming we can, how would we potentially do this? I don't think everybody on the planet needs to live in ketosis. They might throw me out for saying that. Clearly, there are healthy, long-lived, robust people all around the world who don't live at 20 grams of carbohydrate a day or less. They eat fruit, they eat starchy tubers, they even eat grains, right? We can't deny that. So I don't think you have to be in ketosis all the time. I mean, it would be ridiculous for me to stand up here and pretend that strawberries cause Alzheimer's, or parsnips, or beets, or lentils. I mean, that's ridiculous. What I think you do have to do is stay within your own level of carbohydrate and insulin comfort. Some of us are going to have to be under 50 a day. Some of us can eat 150, 200 grams a day and be fine. So do you have to do keto to potentially prevent this? Probably not. Once somebody is already in the disease process, I think you're better off doing something as drastic and as strict as you can if you're going to turn the Titanic around. The primary event leading to the development of Alzheimer's is consumption of an evolutionarily discordant diet. This predicts relatively simple preventive measures. Lowering the consumption of starchy carbs, increasing essential fats might be effective. Simple dietary modifications, fewer highly processed carbs, relatively more fats and cholesterol, likely protective. I had to put the bone marrow down there because somebody once called me out for not having any organs in the presentation. I don't know if bones count as an organ, but liver is not photogenic. Kidneys are not photogenic. Bone marrow can be photogenic if it's roasted and you got the parsley and it's all pretty, but I chose that one. So what does this look like? What does a potentially Alzheimer's protective, potentially preventive diet look like? It looks like all the food we're already eating that is friggin' delicious. This is not a hardship diet. This is not a cardboard, sprouts, tasteless diet. This is fatty meat, fatty salmon, non-starchy vegetables, full-fat dairy, preferably raw, grass-fed if you can get it where you live. It's not legal in all states. Glass of wine maybe never hurt anybody now and then. I think there is hope. Like I said at the beginning, I don't mean to oversimplify this. There's a lot more besides the diet. I wrote a book called The Alzheimer's Antidote, and I talk about fasting, exercise, stress management. I talk about other things besides the diet. But I think we know so much more about this than we're led to believe. And I almost feel bad that I had to be the one to tell you. If today, if me speaking is the first time you've ever heard the phrase type 3 diabetes or heard that the brain glucose hypometabolism is the main problem, shame on your neurologist, shame on your geriatric doctor. I should not have had to say this. I shouldn't have had to write my book. Someone should have beaten me to this 10 years ago. And it's okay that they didn't. It's getting out now, my book, Dale Bredeson's book, Mary Newport's book. I just don't think this is a hopeless situation. So that's my book. If you want to know more, we have a little bit of time for Q&A, but I will be here all day. Please come up. I'm happy to answer questions. Thank you. And I was holding my glasses the whole time because I thought I would need them, but I didn't, so oh well.
That's the best talk I've heard, Amy.
Thank you.
Think that talk alone was enough coming to the session.
Thank you.
You touched a little bit on stomach acid. What do you think about the precursors for neurotransmitters? The precursors for neurotransmitters like phenylalanine, tyrosine, they come from protein. And if you don't have enough acid, I don't know if that makes a difference. I don't know if you care to elaborate on that.
That's a good question. I don't know how much of a difference that makes in that, but certainly you do have to be able to break down those proteins to get those amino acids. And I mean, Stuart Phillips out of McMaster University, he's a big protein researcher. He doesn't really research this. He researches more skeletal muscle, hypertrophy, and all that. He kind of doesn't like when people say, you know, don't go too low on protein because you need amino acids for the neurotransmitters and the hormones. That's probably one of the lesser things of protein compared to building muscle mass. But I agree with you. I mean, why are we trying to get rid of stomach acid? When most people who have, I mean, we all know in this room, most people that have GERD or acid reflux have too much acid, not too little, or have too little, not too much. And even if they did have too much, it's the grains. Why does GERD go away literally in about 48 hours on a ketogenic diet? It disappears for most people. But yeah, good point.
Absolutely fantastic talk. Amy is fantastic.
Thank you.
So, if you wouldn't mind, just because I feel like it often gets lost, but could you actually take us through real quick the early warning signs of Alzheimer's? Because I think a lot of people, it really helps to know that because often you kind of need somebody else to check it for you because they can often see it a little bit better than you can if you're the one that's afflicted.
Yeah, that's a good question because if you are afflicted, you might even know what's going on, but you don't want to admit it. You're not going to go to the doctor because you're scared. This is terrifying, right? Because, you know, until now, we think there's nothing. This is terrifying. This is a really scary illness. You might not want to acknowledge that you think you're going down the path. It differs. The way it manifests in different people is different. Some people, you know, it starts with sort of early memory, what we call senior moments. And I don't want to scare everybody. Everybody has senior moments. But when they start becoming more and more common and they start affecting your life, I've heard reports from people like CPAs, accountants that do a lot of math in their professions. They find that they can't calculate as quickly in their head. You might forget words for things like that metal thing on the table because you don't remember the word fork. It could be subtle like that. So, and I think it varies from person to person. And you can actually have your brain glucose metabolism measured via PET scan. I don't recommend it. But if you are somebody who thinks you are on the path to this disease, that might not be a bad idea. I think I'm out of time.
No other questions? Going once? Amy Berger, ladies and gentlemen.
All right. Thank you. Thank you.